Alright, welcome to today's video that will look at how to take the derivative of a logarithmic function, base e, which is Euler's number, as we found out in our last video. Taking what we know about logarithms, if I have the exponential statement y equals e to the x, we should be hopefully familiar with now how to switch that and say, well, this also means log of y to base e is equal to x. Well, log base e actually has a special name. It's called natural logarithm. And natural logarithm simply means log base e, and it has the notation, usually it'll be a script ln, base y equals x. So when you write ln, it's understood that the base is e, Euler's number. In the same way that if I just write log of 75, and I don't put any base there, it is implied that that means base 10. All right, so Euler's number is implied when we use what's referred to as natural logarithm. So knowing that, if I said, well, let's see if we can find the derivative of the natural log of x. So again, you may say, well, I don't know how to do that. I don't have any rule for it, which at this point we don't. We're going to uncover one here pretty quickly, though. What we're going to do is switch this to exponential notation, because we do know how to find the derivative of an exponential function. So I'm going to say this is base e, so e to the exponent y has to equal x. And we know from our last instructional video that the derivative of e to the u is e to the u times du. Well, here's e to the u. So this is going to be an implicit derivative. So the derivative of e to the u is e to the u multiplied by the derivative of u. So the derivative of my exponent would be dy dx because it's the letter y. The derivative of the letter x would just be a 1. Oops. That tells me then that dy dx is 1 over e to the y. Well, I know from earlier, if you look up above here, e to the y is simply equal to x. So e to the y, it says right here, e to the y is equal to x. That can be replaced with an x. There you have it. The derivative of the natural log of x is 1 over x. Let's try that with something besides just x. Oops. Let's find the derivative of the natural log of x cubed. Now, this exponent, notice it's not on natural log, so we will run in eventually where we'll have something like ln of x, and the exponent will be here. That means, like it does with trig ratios, natural log of x all to the exponent 3. However, what we're doing here is finding the derivative of this by switching it to e to the exponent y is equal to x cubed. Use my implicit differentiation, so e to the u times du equals the derivative of the right side, 3x squared. Rearrange for dy dx. So that's 3x squared over e to the y, and we know that e to the y is x cubed. So I want you to notice the pattern here, that hopefully it will lead us to a rule to take the derivative of the natural log of u, where u is some differentiable function. And what happens is the numerator is the derivative of this is called the argument of your logarithm. So it's 1 over the argument multiplied by the derivative of the argument. So if you have ln of u, the derivative is 1 over u multiplied by the derivative of u. Oops, too far. So this would be the rule that we would now also add to our list. So that's how we take the derivative of a logarithm base e. Well, let's just jump to an example or two just to make sure we understand what's going on here. So if I have y equals the natural log of 7x to the fourth, y prime would be 1 over 7x to the fourth multiplied by the derivative, which would be 28x cubed. Now this could just be slid over to put it as du over u if you like, but we'd like to have you understand that it could also be 1 over u times du in the event that your du is maybe something a little bit more complicated. I'll show you. Let's say, for example, I have the natural log of inverse cosecant, something we looked at earlier in our derivative rules, of x cubed. So now it's natural log of, this is the argument, so y prime, hitting a button here. So y prime would be 1 over u. Now I need the derivative of this. Now the derivative of inverse cosecant is negative du over u under the square root of u squared minus 1. So I don't want to put all that up here. I'm going to put my du then beside it. So it's negative du over u multiplied by u squared minus 1. Okay, so that's how your natural log rule works. So again, we would just add that to our list. And that's all that I'm going to go through in this video. So right now, we are able to differentiate exponential functions base e and logarithmic functions base e, which are referred to as natural logarithms. So in our next video, we're going to extend to be able to take the derivatives of exponential and logarithmic functions to any base. Thanks for watching.